started. Problems on AC circuits. First problem, a tuning circuit consists of 14 picofarad capacitor and the inductance of its coil is 5 millihenry. Picofarad should be converted into farad. It is multiplied by 10 power negative 12. Millihenry should be converted into Henry multiplied by 10 to the power of negative 3. What about this tuning circuit? It receives a wireless wave of frequency 600 kilohertz. Okay. If the coil is replaced by another of inductance 15 millihenry, so we've changed the inductance. L is changed into 15, okay, and the capacity of its capacitor is increased by 28 picofarad. It is increased by 28 picofarad, not increased to B, okay. And now calculate the frequency of the new wave that can be received by the circuit. Okay, what rule to be used here? Okay, it is at resonance. And first of all, C1 equals 14 picofarad, so it is multiplied by 10 power equals, yes, 14 times 10 power negative 12 plus 28 times 10 to the power of negative 12. It is 42 times 10 to the power of negative 12. And what about the inductance? It is 5 times 10 power negative 3 Henry, and it is increased, or it is changed, okay, into 15 times 10 to the power of negative 3 Henry. The formula used, F1 over F2 equals L2 C2 over L1 C1, okay, because F equals 1 over 2 pi square root, yes, LC. So 600 over F2 equals 15 times 10 power negative 3 times 42 times 10 power negative 12. L1 is given to be equal 15 times 10 power negative 3 times C1, which is 14 times 10 power negative 12. In this way, F2 is calculated and it is 200 kilohertz. Okay, it will be in kilohertz since we used F1 in kilohertz. Find the readings on the voltmeters, knowing that the effective value of the current through the circuit is 2 amperes. So current is given. In the following circuit, we've got the current, it is equal to 2 amperes, and we want the readings on each voltmeter. Okay? In front of you, we've got a circuit, a current of 2 amperes is flowing through it. Okay, 314.28 rad per second is the omega. Okay, ohmic resistance equals 50 ohm, inductance given in millihenry 63.66, C capacity equals 1.59 times 10 to the power of negative 4 farad. We want the reading on V1, V2, V3 and V4. Okay, we'll do it one by one, but first of all we need to calculate XL, inductive reactance, and we'll do the same concerning the capacitor, capacitive reactance. Okay, let's take it one by one. Omega L equals XL. Okay, so it is equal to 314.28 times L given in front of you 63.66 times 10 to the power of negative 3. Okay, it will be equal to 20 ohm. Will you please keep it, bear it into your mind? It is 20 ohm, the inductive reactance XL. And what about XC? It is 1 over omega C. So it is 1 over 314.28 times 1.59 times 10 power negative 4. It will be also 20. XL, when XL equals XC, we've got a resonance state. And what about resonance state? In that state, V total equals VR. V total equals VR. Okay? So V total equals VR, and it is equal to IR. I given in the problem in the very beginning, it is equal to 2, resistance 50, so it is 100 volt. V total is equal to VR. We managed to obtain two things. Okay, and now we want V2. V2 is the voltage across the coil. Yes, it is IXL. I times XL equals XL. We managed to obtain it. It is 20, so it is 40 volt. And V3 also equals 40 volt. The question now, how to calculate V4? It is the difference between V2 and V3, so it is 0. So 40 minus 40, it is equal to 0. Another problem, calculate the potential difference across each element of the circuit, the following circuit of course, and the power consumed in the circuit. So a circuit will be shown to you right now. Okay, what about the figures we've got? 200 volt, it is the effective value of the voltage, frequency 60 hertz. We've got an ohmic resistor, its value 44. Yes, the coil has an ohmic resistance of 36 ohm, and in reactance, inductive reactance 90 ohm. Capacitive reactance is given to be 30. So we need to calculate the impedance of the circuit, Z. It is equal to square root RT squared plus XL minus XC. RT means, our total, the total ohmic resistance in the circuit. We have two ohmic resistors, 44 and 36. Okay, so 36 plus 44, 80. So Z equals 80 squared. XL is given to be 90 minus 30. Okay, so Z equals the square root 80 plus 60. Of course, it will be 100. So we've managed to obtain the impedance of the circuit. So it's all easy for you to calculate the current. Yes, how? V over Z.